Okay, so we are going to talk about a very important concept under light, and that concept is dispersion of light. So when we say dispersion, the word dispersion means to scatter. So dispersion of light means scattering of light. Now you should know that the true color of light is white. The true color of light is guinea white. Now, if I bring a triangular prism, this is a triangular prism, and I pass white light through that triangular prism. This is white light, white light. So if I pass white light through that triangular prism, you will see that different components of light will emerge differently. They will emerge differently. So, and what are those components of light? There are 7 components of light, from red down to violet. So you have your Roy Beeve. You have your Roy Beeve. Those are the 7 colors you see during your rainbow. So that is what we call what? Dispersion. So dispersion is the scattering of light. So when white light is passed through a triangular prism, what happens? It scatters into its various components, meaning it disperses into its various what? Components. Now, what we are seeing here is what we call an impure spectrum. An impure spectrum. So in JAMB exam, they will ask you, why do we call this an impure spectrum? You tell them it is because the various colors overlap. The various colors of light overlap. Now, forget the fact that I drew it very beautifully like this. In real life, these colors are going to overlap, meaning you are going to see the colors on top of each other, red on top of yellow and so on. So they are going to all be on top of each other. Because of that, it is called an impure spectrum. An example of an impure spectrum is your rainbow. So you normally see during the rainy season, let's say after. Okay, so we have a bee here. So we have a rainbow. So sometimes during the rainy season, after it finished raining, you will see a rainbow in the sky, which is a ring of colors. A ring of what? Colors. So that rainbow is called an impure water spectrum. It is called an impure spectrum because when you see the rainbow, you don't see all the colors very clearly. You see that they will be on top of each other. There is no separation of the colors. They are kind of on top of what? Each other. That is why it is called an impure spectrum. Another question JAMB will ask you is, how do we produce a pure spectrum? Since we said that this one is an impure spectrum, how do we produce it? Now, for you to produce a pure spectrum, you need 2 convex lens. You need 2 convex lens, and you need a triangular prism. Okay, a triangular prism. A triangular prism, just like this one. Okay, a triangular prism. So the setup would be, this is a convex lens. Triangular prism will be between the 2 convex lens. So your light will pass through the 2 convex lens. So for you to produce a pure spectrum, this is the condition. Take note of that. So the condition to produce a pure spectrum, you need 2 convex lens, you need a triangular prism. I have seen a question in JAMB where they said in which of the following can be used to produce a pure spectrum. And in the question you see something like convex lens, triangular prism, convex lens. Another option you see convex lens, triangular prism, concave lens. Another option you see concave lens, triangular prism, and so on. So they will mix it up. So always know that you need 2 convex lens and a triangular prism. And the setup is convex, triangular, convex. That is always the setup. So don't try to confuse that. Now, another important thing they will ask us under this dispersion is, they will ask us, why does it occur? Okay, why does dispersion occur? The reason why dispersion occurs is because the various components of light. What are the components I'm talking about? I'm talking about the Roy Beeve. Okay, now Roy Beeve, if you don't know, stands for red, orange, yellow, green, blue, indigo, violet. So these different colors are the different components of white light. So the reason why dispersion occurs is because the various components of light travel at different speed. So all these colors, they travel at different speed when they are in glass. But assuming they traveled at the same speed, it means that they will just come out as a single ray of light, which is still white light. But because they all have different speed, when they enter into glass, their flaws will start showing up. So some of the colors of light are faster than the other. So because they have different speed, they will emerge separately, and you will have this dispersion that we just talked about here. Okay, now another question they will ask you here, of course there are several questions that will come out from this Roy beef. One of the first questions they will ask you is, which of the following colors deviates the most, and the one that deviates the least? So looking at this, just from this arrangement, Roy beef, from this arrangement, you should know that deviation is increasing from red to violet. Deviation is increasing. Deviation is increasing. Make sure you are taking note of that. Deviation is increasing from red to violet. Now, what does that mean? It means that red has the least deviation and violet has the most deviation. So deviation is increasing like this. Red has the smallest deviation, or you say that red deviates the least, and then violet deviates the what? The most. In an example, you might see something like, okay, let's say we have this C, D, and in option A you have I, option B you have B, option C you have O, option D you have maybe G. Look at this now. So these letters represents the colors of light, and the question is now, which of the following colors is the most deviated? Which of the following colors is the most deviated? Looking at this now, looking at all these colors, if you see that answer will be what? Indigo. Answer is going to be what? Indigo, because after indigo you now get to what? Violet. But because violet is not in the option, answer becomes what? Indigo. Okay, so that is that. Another question they can ask you from these colors is that they will ask you the color with the highest speed. The color with the highest what? Speed. Meaning, which of these colors travel fastest? Which of the colors travel fastest? And all you need to remember is that if I'm going from red to violet, speed is decreasing. What did I say? Speed is decreasing. So as I'm going from red to violet, speed is decreasing. What does that mean? It means that red travels what? Fastest. The fastest of the colors is what? Red. And then the slowest is what now? Violet. The fastest is red, slowest is what? Violet. Take note of that. Very, very important. So if you look at this question now, and then they said, which of the following colors has the highest speed in glass? Has the highest speed in glass? What is it going to be? Think about it. So looking at these colors, which of them will travel fastest, highest speed in glass? So which one will it be? You see that it is going to be what? Orange. It is going to be orange, because of course you don't have red here, and because there is no red there, the next one in line is what now? Orange, which is the highest speed. So if I say decrease, it means from the highest to the what? Lowest. That is how it happens. Now, again, they will ask us, which of these colors has maybe the highest or maybe the lowest what? Refractive index. So these colors have different refractive what? Index. They have different refractive index. Okay? They have different what? Refractive index. So they will ask us the one that has the highest. Now all you need to know is that from red to violet, refractive index is increasing. Refractive index is increasing, meaning that red we have the smallest refractive index, and then violet we have the highest what? Refractive index. Remember, violet travels the slowest. It is the slowest among all of them, and because of that it has a high refractive index. So it has the highest refractive index, while red has the lowest refractive what? Index. So take note of that. Okay, so another question they can ask you here is about what? Wavelength. You should know that wavelength decreases. Wavelength decreases from red to what? Violet. Wavelength decreases from red to violet, meaning that red has the highest wavelength and violet has the what? Lowest wavelength. And you should know that the higher the wavelength, the more visible it will be. So when you look at a rainbow, you see that the color you see the most is what? Is red. So red is the most visible color during a rainbow because it has the highest wavelength. So these are the questions they can ask you when it comes to the case of what? Dispersion of light.